going to look at increasing intervals. What does it mean to increase? To get bigger, to go up. Okay, so increasing intervals is the interval of x where y increases. Goes up or gets bigger. Okay, and I want y'all to draw an increasing line to the side. And when we do this, it is an interval, and you look at the x values from left to right. All right. None of that's necessary. Find your seat quickly and sit down. You shouldn't be that close to his chair.
Is it okay if Sam is wondering if I can still stay in the library because they need help for picture stay cover?
All right. Now we're looking at decreasing intervals. Okay. So for decreasing intervals, that is going to be intervals of x where y decreases, or what else could I say? Gets smaller or goes down. So intervals of x where y decreases, goes down, or gets smaller. And we're going to draw an example of a decreasing line. And again, this looks at your x values, and you go from left to right. Okay. Then we're going to look at constant intervals. So if increasing is going up, decreasing is going down, what is constant? Staying the same. So it's intervals of x where y stays the same. What would a line where y stays the same look like? Horizontal line. And again, that is x values from left to right. What is our y-intercepts? It's where it crosses which axis? The y-axis. Okay, our y-intercept is also where x equals 0. And when we write this, we're going to write a point. And the point we're going to write is 0, y. So it'll be 0, whatever the y is. If it's a function, it's only going to have one of those. If it has more than one, it's not a function. X-intercept crosses the x-axis. Or where y equals 0. Okay, that would be the point x, 0. Did I know what? I just didn't hear you. All right. X-intercepts, you can have multiple of them. You can have as many as you want. Like, it doesn't matter how many there are. But there are other names for them. Sometimes they will be referred to as x-intercepts. Sometimes they will be zeros, roots, or solutions. Any of those names mean x-intercept. Kipton, go to class. Yes. You have stuff going on. All right. So we are going to look at the graph below, okay, and answer all of the questions. So what we're going to do first is I'm going to sketch on the line, and you're going to tell me if it's increasing, decreasing, or constant. So is this part of our line increasing, decreasing, or constant? Increasing. When we write intervals of increasing, we look at our x values. Where does that start on our x-axis? And it goes to? So we will write our interval from -4 to -2. Now, we will only use parentheses when we are doing intervals of increasing, decreasing, or constant. And the reason for that is you cannot increase at a point. So my example that I like to think of for that is if we are watching Fast and the Furious and it's zooming in on their little speedometer, right? And they're speeding up going real fast, right? And it's like the speedometer says 97, but it's climbing. So it's like 92, 93, 94, 95, 96, 97. If we pause it when it says 97, how many speeds are on the speedometer? One. If I just showed you a picture of it that had a speedometer with 97, would that be, could you tell if it's increasing or decreasing? No, you couldn't tell from just a speedometer, right? Because you don't know if they're pressing the gas, you don't know if they're pressing the brake, you don't know what's happening. At a singular point, you cannot tell if it's increasing or decreasing. So it can't be included. Because in order to know if it's increasing or decreasing, you have to look at a pattern over time. So that's why we don't include the ends, because we don't know. We don't know if at that point what it's doing, okay? So we do not include the ends. We only use parentheses for increasing, decreasing, and constant intervals. So now, the next part. What is this section doing? Decreasing. So where does that start decreasing at? -2, and it goes to? So it will be from -2 to 0. Now we're going to look at this section. What is that doing? It is constant. Where does it start being constant? And it goes to? All right. Now, the next section, what is it doing? Decreasing. Where is that decreasing from?
2 to negative.
2 to 5. We use the y values. Or we use the x values. We use the x values. Okay, it goes from 2 to 5. Now, it is also decreasing. When I need to use two intervals, how do I connect them? Use a U. Okay, so we'll do U, 2 to 5. What is that last section of our graph doing? Increasing. Where does that increase from? 5 to 10. So we'll do U, 5 to 10. So when we do increasing, decreasing, and constant, we are looking at intervals of x. We're looking at intervals of x from left to right. Now we're going to look at where is the zeros? Zeros are what? X-intercepts. How many places does this graph cross the x-axis? Twice. So when we answer these, we do points. What are the points?
4 and 9.
How would I write those as points, though? So 4, 0, and 9, 0. Okay? We do those as points. Then y-intercept. How many y-intercepts do we have? 1. Where is it at?
0.
So it would be at the point 0, 4. So whenever we do intercepts, we are looking at points. They may look similar, but they do not mean the same thing. Okay? This means from 0 to 2. This is the point 0, 4. It's different, okay? So it's important to know the context of the question it's asking. All right, Now we're going to look at domain and range. So for domain is our what? X. And we go from left to right. What is the leftmost part of that graph?
-4.
And it goes to
10.
10. Now, both of these points at the end have closed circles, so that means
Bracket.
for range, that looks at our
Y.
Y's. So if we are looking at Y's, that will be our Y values, and we're going to go from bottom to top. What is the lowest Y value we have?
-2.
What's the highest Y value?
6.
And if it's not open, we use brackets.
Stop touching my foot.
What is the maximum?
No, it's not. Wouldn't it be right? No.
Mm-mm.
It is 6.
We're looking at the lowest Y value. It is down here at -2. All right. What is the maximum value of the function? What is the biggest that function ever gets? The- What is the tallest that function gets? 6. At what X value does that occur? -2. Okay, now, what is the minimum value of the function? -2. What X value does that occur at? And so that is what we are doing in 3.3. We're going to do some more examples of that tomorrow, but today we're going to finish up with some practice from yesterday. So I'm going to pass it out. It is something that we are going to do and turn in. As soon as you get it, start working on one, and then we're going to go over certain problems. And some of them you'll do yourself. I think those are
The math class. It's me and Tyrone.
Yeah, I've noticed that there's some scribbles on the desk.
And it's Christina. Yes, that's Christina.
Bro, Tyrone
He said hey Christina. It's Tyrone.
Tyrone really, he came up to us. He was a bit. Yeah, he was like, well, y'all was doing sing.
All right. So we're going to go ahead and we're going to look at question 1 and talk about how to do it. All right. So we are going to look at 1. So as 1 is f of x is equal to 10 minus 3x. And then it asks us to find f of 2. What do you do there? Plug in 2 for x. So we're going to do f of 2 is equal to 10 minus 3 times 2. What is 3 times 2? What is 10 minus 6? So f of 2 is 4. That is what you do for all of the problems in 1. You just plug in for x. Okay, for question 2. Okay, for question 2, you have g of x is x squared minus 7. Complete the table of values for g. What do you think we need to do with all of those x values? Plug them in. So we're going to do g of -3. So we get -3 squared minus 7. What is -3 squared? Positive 9. What is 9 minus 7? 2. So that is the first point on our table. Then we're going to do the next one. G of -2 is, what is -2 squared?
4.
What is 4 minus 7? -3. Okay, then we're going to do the same thing, but we're going to do G of -1. So -1 squared is 1. What is 1 minus 7?
-6.
Then we're going to do G of 0. What is 0 squared?
0.
What is 0 minus 7?
-7.
Then we're going to do G of 1. What is 1 squared? What is 1 minus 7? And I will leave you 2 and 3 to do on your own. All right. And we're going to drop down and look at question 3. So for question 3, it gives us a table for function h of x and a graph for function h of x. So we are going to evaluate the function h. So we are going to start at h of negative 2. Is negative 2 in the table? No. So I have to look at the graph. So looking at the graph, when x is negative 2, what is our h? When it's negative 2, that is here. So what is the y value there? 0. So h of negative 2 equals 0. Okay. Some of the papers have typos for question B. If yours is one of them, you can cross that out and put h of 2. I caught it about halfway through printing and then I fixed it. So h of 2. So 2 is not in our table, so we got to look at our graph. So if I go to where x is 2, what is y? Negative 2. We just find those points on our graphs. Okay, now we're going to look at h of negative 3. Is negative 3 on our table?
Oh, yeah, it is, yeah.
So what is h of negative 3?
Negative 12.
All we are doing is finding the points, whether it be on a table or on a graph. All right, you will do D and E, okay? And we're going to go ahead and look at question 4. So question 4 says selected values for a function g are given in a table. So g is our table. Then it says the graph of function f of x is shown. And let the function h of x be h of x is equal to 10x minus 7. So it gives us 3 different functions. So if it asks for h of 12, which function do you use? H. If it asks for f of negative 7, what function do you use? F. If it asks for function g of negative 3, what function do you use? G. Go ahead and do A.
2023-78, Sherry Bowles, Randy Shelley, Bus, 2026-87. Randy Shelley, Bus, 2026-87, split. Self-Earth, Schreiber is going to be Randy Shelley herself, 2026-87. She'll be taking Cottage Hill and Capital, Cottage Hill and Greenland, Chapel Hill Drive at Cottage Hill. The second bus driver is Connie Skelton, and 2022-35, she'll be taking Leroy Stevens at Waterport. Leroy Stevens at William Apartments. Alright guys, we made it another week. We have Friday tomorrow. So we will see you back early and happy today. So great to be recording. Bye.
All right. So it is just finding the point. We go to x is 2. That means y is 4. So f of 2 is 4. Now, to find g of 4 plus f of 4, before I can add it together, I have to find both. So we're going to start with g of 4. So which function do I use for g of 4? Do I use g, f, or h? G. Okay, it's on our table. What is g of 4? Negative 6. Okay, then we're going to do f of 4. So f of 4, we use f. So at x is 4, what is y? So to set this up, we will do negative 6 plus 3. What is negative 6 plus 3? Negative 3. Then we're going to do the same thing with h of 2. So with h, we have to plug into the equation. So it'll be 10 times 2 minus 7. What is 10 times 2?
20.
What is 20 minus 7? Okay, then we're going to do g of 2. What is G of 2? 3. So to evaluate this, we do H of 2 minus G of 2. What is 13 minus 3? Okay, then D is for you to do. Before we move on, I want us to look at E. So it says, which of the functions has the greatest y-intercept? When it's a y-intercept, it's where it crosses the y-axis or where x equals 0. So what is f of 0? So I go to where x is 0 and f, and what is that? 6. Then we're going to look at G of 0. So I go on the table. What is G of 0? 5. Then we have H of 0. I plug in that. So 10 times 0 minus 7. What is 10 times 0? What is 0 minus 7? So which one of those has the greatest y-intercept? F. And you are responsible for finishing the rest of those. It is due at the beginning of class tomorrow.
Oh, at the beginning.
So it is homework if you do not finish it in class today.
I've never seen gray sweatpants as shorts. I've never seen like gray sweatpants shorts before. Oh yeah. Gray sweat shorts. I got a black pair.
No, because that's
Where does one get sweat shorts?
I thought I was
I just know
their therapy.
Nathan.
Jasmine was getting on my nerves.
Nathan. I just know
It'd be 6 o'clock.
What?
It'd be
I
6
know
o'clock
people.
in the morning. Jasper eating
Where you
burgers.
going?
I can't even find it.
No, I know people, bro.
I'm gonna find them. Oh my god. So this one be my shirt and this one be my pants. I could walk out with this on his skirt. Oh, here. I'm so sorry. Hold on, where my pants? If I do a squat, I might. Is that tight? No.
Good one, wasn't it? I like mechanics.